Okay, coming back into our video, I always have something I want to say right at the end and I get cut off. So part two of our video here. I was talking about how I call this original function on f of x in general, even though we named this one g of x. It only really works if it's f of x, but you can get the idea. There's the original function, and then over here, after you simplify, it's the reduced function. And so I have a tendency to call the reduced function Fred. And so if the reduced function is Fred, Fred knows everything about the rational function. He knows where the zeros are. He knows where the undefined values are. Anything that was removed becomes the exception that's written right here, which tells us that we have a point discontinuity, and so on. Now, I did want to talk about, what we mean by a removable discontinuity there. So I thought maybe I would really quick before we get into the solving, just slide over and talk about why we say that the discontinuity can be removed versus saying that I just canceled. So if I had as a side comment, okay, so alternate example, if I had x plus 1, x minus 3 over x plus 1 squared, x minus 2. Suppose that was my function f of x. And so in going to simplify this one, now we definitely know that f of negative 1 is undefined. We know that f of 2 is undefined. So those are both going to be discontinuities on this rational function. Now I cancel, and I can cancel, okay? I can cross off 1 in the numerator and 1 in the denominator. And so the reduced version of this is going to be x minus 3, x plus 1, x minus 2. Notice that the x plus 1 factor, it was not removable. Even though I could cancel it, it was not removable. And so what that means, if you actually graph this, and I'll let you guys do that on your own, go to Desmos and simply type in the original function f of x. And if you graph it, you will see in both x equal to negative 1 and x equal to 2 are going to be vertical asymptotes on that graph. They're not removable. So canceling is not what makes it a whole. It's being able to cancel it out and remove it. And sometimes there will be other techniques in calculus for removing that discontinuity that may not involve factoring. So that's why it's not the canceling that we're looking at, it's the removing it from the denominator that is what we're talking about. All right, so now we're going to come down to the next page and we're going to talk about our solving. Sorry, I got my office chair and it rolls. And I will try not to do this the whole video because I have a tendency to twist my chair around now that I have a swivel chair. So sorry, I know it's distracting. I noticed it in the last video. All right, so solving rational inequalities. So it's same as what we did before with the sign analysis, but there's one more thing that's going on here that we want to be cognizant of. Our critical points before had been where our function f of x or g of x, let's use g since that's our function. Critical points that we found before were where g of x was equal to 0. And then we would add them to our sign chart for our sign analysis. But I'm going to say, and now that we have rational functions, anytime that g of x is undefined, we also consider those critical numbers. And so we do want to make sure that we are paying attention to those values as well. So when we've already done the work for this, so I'm just going to show you the work for solving this. Sorry, for some reason I prefer myself on this side, even though it gets in the way. All right, so let's look at our steps. We have this inequality now. So again, we're assuming that we don't know all the prior information. We don't have the graph, but you always start out your rational function. And I will tell you that in general, and it doesn't really say that, but you need to have a 0 on one side. So get 0 on one side. That's number one, okay? And then if it is not nice, like this one is, on this side, you want to combine into a single fraction. So these two steps are actually something that have kind of already happened in this one. When I say combine into a single fraction, that means get a common denominator, add or subtract if you're moving from one side to the other. So simplify using your algebra skills to get a single fraction on one side and 0 on the other side when you are doing this. So once you have that, if you can, you are going to factor the rational expression. So it becomes x plus 3, x minus 1, and x plus 3, and x plus 1, and less than or equal to 0. So we factor the fraction that we have over here, and we're going to write down our critical values. Now, we could simplify this. I mean, that's perfectly fine, and we don't usually write down things like the exception down when we simplify it, but we do have to be cognizant of the fact that if I canceled, I do want to make sure that I am recognizing that the act of canceling that factor right there, that the critical points are going to be x equals -3 and -1 because g of x is undefined, okay? And x equal to 1 because g of x equals 0. That those are the critical points that we are going to put in the sign chart. Now, I'm going to just shrink this down as always. I have a tendency, although I guess technically this should have gone up here anyway in that box. So I'm just going to move it up, and I'm going to move this up, and I'll shrink it down a little bit. And then I'm just going to change the color because I want it to stand out. All right, so we get those critical points. And then once you get the critical points, now you're going to do the sign chart analysis. So we're going to draw our number line. And then on this number line, we're going to put these three critical values. And so our three critical values are starting over here. So we have a -3, a -1, and a 1. And again, I don't worry about spacing because it's really not that important. I do like to put above what was going on. So I like to put a big U over the things that were undefined because that tells me information about the graph and about including and not including, especially notice that here we have a less than or equal to. And so having a less than or equal to means we're going to include the zeros. So I kind of need to know which of these endpoints are actually zeros versus undefined. Okay. We're going to do the same thing that we did with the polynomial functions. We are going to test. And now, luckily for us, once you've done this, and I'm going to test the values. So test a number in each interval. And at this point, this is also the beauty of Fred, is that you can use the simplified version. It's much easier. So I'm going to say ask Fred to help us out with that. Because what we're really basically doing then is I only need to plug and chug in this to determine my sign, a lot less information going on. And I can do a lot of that in my head. So if I'm going to look at, say in this interval, I might test -10. Here I might test -2. I could test 0 and test 10. So those are all the values that I'm just going to plug them in and in my head think about it. So if I put -10 into this Fred, which is right here, -10 minus 1 is negative, -10 plus 1 is negative, and a negative over a negative is positive. So we just fill that in as positive. So it's pretty quick. Just, run through each one. We put in the -2 is going to be a negative over a negative still, so positive. Then we plug in our 0, which is going to be a -1 over 1, which is negative. And then I put in 10, which is going to be positive over positive, which is positive. So very quickly, we kind of have laid out our sign chart. And so, and then kind of relating this back to the graph that we saw earlier, notice that the positives will be the places where it is above. The negatives will be places where it is below. The zeros will be places where you are on the x-axis. So these are x-intercepts. And then where it's undefined are going to be discontinuities, holes or gaps in the graph. And that's either going to be a hole in the graph. For a rational function, it's either a hole or a vertical asymptote on the graph. So we have that all kind of laid out. We refer to the original inequality sign that we have, our less than or equal to. So less than or equal to. So we want to make sure we choose the negatives, and the 0. So in that, I'm going to go ahead and highlight it here in green. Here's the 0. Here's the negative section. And notice that I'm not going to include, and I might come in here and put an open circle. Like if we were doing this in terms of shading on the number line, I'm kind of doing open circle, shade, and then a closed circle. So the solution that we have would be parentheses, -1 to 1 with a bracket. And I think I just did those backwards. No, I did those right. Oh, yes, I did do them backwards. -3. Did I factor that wrong when I did it? I did. Just ignore me as I'm looking at this. Let me come back in. I was copying this down from above and then I immediately did it wrong. Now I just noticed it. So that would be a -1 and this is a +1 there. I put it right, and then I did it wrong here too. Sorry, I apologize. We're going to fix that right now. This is live TV. I'm not redoing this video. So this one was 0 and this one was undefined. Helps to make sure we don't make careless errors. And that would mean that as I am doing this, oh Lord, took away my number line. Let's add that back in. And that means that this is closed and this one is the one that's open. See, I knew that because I also knew what the answer was. And we'll switch that around. So we have a bracket and a parentheses, and that should match what we got earlier. Okay, sorry about that. So that kind of gives you the idea of the steps that you're going to follow in. Just make sure that your sign analysis includes your discontinuities, your critical points, as well as places where it is undefined. Make sure you label them, of course, correctly. It helps if we factor correctly when we're doing it, and choose your answer. All right. In referring to the graph at the right, explain how the sign analysis in the process above is confirmed by the graph. That a plus graph is above. Oh, sorry, I'm not on the screen. So the graph is above the x-axis. Negative graph is below your x-axis. A 0 is an x-intercept on g of x. And if it is undefined, it has a discontinuity, either a hole, which is a point discontinuity, or a vertical asymptote, which is an infinite discontinuity on the graph. All right, so now I have another example, and I'm going to let you guys go ahead and try this example on your own, ask you a few questions, and see how you did. All right, coming back in to go over that last problem, I did add up here that the factor was removable for the holes and not removable for the vertical asymptotes, just to have that. All right, so taking a look down here at our work for the sign chart, it's already factored. It did not simplify, so it was super easy. We take a look at the sign chart, my test values. One thing to notice is that the denominator, because it was squared, was always positive, so that's always an easy shortcut to pay attention to. We were doing less than, so it was only negative included, so make sure that we took out the -2. And then at the end, I went ahead and did these, basically the same thing I had before above. Check your answers in the key. What I would like you to do now is try all 3 of these. We'll come back in the next video and discuss them in more detail.